Is everybody back from coffee? Great. Okay, last people go sit down. So I'm Jeroen Massar. I'm originally Dutch, but as my tag here says, I'm from Switzerland nowadays. And as such, I am the Swiss part of Farsight Security. As some of you might know, Paul Vixie, he is the guy who made Bind popular at ISC. And we split off from ISC last year, so the Internet Systems Consortium, to become Farsight Security. And we took along our Security Information Exchange and the DNS database. I will not tell much about SIE. I will tell a little bit about DNS database because that's sort of involved in this whole setup of various tools that we're providing and protocols that you can use as that's open source in many ways. So who knows how the DNS works? I want to see hands. Good. Look, people know how DNS works. That's awesome. So I can skip this slide, I guess, then. But to go over very quickly, you have an application, which is maybe your browser. The browser will, I want to point at the laser at the screen here, but that won't work because then you won't see it. But the application will ask a stop resolver, which is local, for a name, www.ripe.net or something like that. It will then ask the recursive server. The recursive server might serve it from cache, or it might ask the authoritative name server, which will get it from zone data that it actually has. So that's a little bit the DNS thing. Now, in DNS, we have a lot of margin of problems. One of the big problems we have at the moment is all these NTP distributed DDoS attacks, which are typically reflective. So who has a TLD or who runs a name server and has been DDoSed in this respect, or has been abused for denial of servicing another operator? Anybody here? Nobody? Oh, some people. Great. Well, no, not great. Bad. But at least, well, there's some people who have had this effect. Well, because of these attacks, and also not only because of the reflective DDoS attacks currently happening, also with NTP in mind, and also with other various things, the big problem behind it is actually that people are able to spoof. So as I understand here in Russia, spoofing is a rather bad thing and a common thing. So this is something we'll have to address. But there was a talk yesterday already about BCP38. I have a slide coming up about it. But one way to solve this for DNS is not answering every question that you get. So there are people who just do a IP tables kind of firewall, and they say, well, every source address is allowed to do 5 queries. If the next 5 queries come in the same minute or something, we just drop those and we ignore them. But that way, if the request is spoofed, it might be that you're dropping legitimate questions. Which is also, of course, a denial of service. Because if you're an attacker and you're sending packets out and you're asking like 10,000 questions, the real source will not ever be able to answer questions anymore. And that might break their infrastructure in unexpected ways. So one thing that you can do is you can use RRL. If you have bind or if you have NOT or NSD, these fortunately now all implement this system. And you can thus set up RRL. I'll have the bind config on the next slide. And what this does, it will keep a cache, a little list of entries about the unique responses it is giving. And it will keep a counter for each /24 or IPv6/48, or depending on your configuration, how you configure it. And that way, if you're asking for the same question 5,000 times, like what they used to do at ISC, that they would ask for ISC.org, which had this nice large DNSSEC records and very fast servers because they were all co-located with the froot servers, which are globally distributed. You can generate a large amount of responses. So with RRL, you rate limit these requests, but because you are only rate limiting on the unique responses, you're not denying anybody information. Because if you ask now what the address is of www.enog.net, you'll ask it 5 seconds later, it will probably be still the same. And thus, there is no need for the asker, the attacker, which might be spoofed, to ask a question twice. You can find more details about this on the website at the bottom. And for instance, this is the simple way of configuring this in bind. You just add a rate limit statement in your options section. You set the responses per second to, well, say maybe 15. You give it a window of 5 seconds. And then you will see, as you can see here on the slide in a nice graph, that is from the Amsterdam node of froot servers. That's a slide actually by Peter Loscher of ISC. That when they implemented RRL, somewhere on the left there with the blue little line, the attacks were coming in. That's the big purple stuff, or well, the green stuff, and the purple, so the northbound stuff, the positive side, is what the results were, what they were sending back as answers. And when they implemented it, it just more or less flatlined. And after quite a while, as you can see, they just gave up. The attackers realized, like, hey, IC.org is cannot be used anymore as an attack mechanism, because it's, well, they are rate limiting now, and thus we need to find other recursors or authoritative servers which we can spoof and let them respond to it. So it's a very effective mechanism, and unless you think, well, I am not a big enough fish to fry and they will not attack me, you shouldn't implement this, but I would suggest enabling it. It cannot hurt, but it does give a really good effect on your network stability. Because if you're flooding out the 60 megabits there instead of the, what is it, 10 mbit that they normally would do, that's a 6 times more traffic amount. And if you're going to send that over transit, you're paying for it. And I don't know what you pay here in Russia compared to, for instance, Australia, but I guess that you pay quite a lot more for transit than what we pay, for instance, in the Netherlands or in Switzerland, anywhere in mainland Europe. So the more important thing is RRL is one way of defending it, but that would affect for DNS attacks. If you want to also do this for NTP, if you want to do this for every single thing that can be spoofed, you have to make sure that you have your network do BCP38 so that you cannot source any spoofed addresses anymore, but also cause that all the networks that you're connecting to, so for instance at the IX, your transit partners and everybody you peer with, that they also implement BCP38. Unfortunately, the thing is, even if 100 people have implemented it, if there's one bad person who hasn't, they can still spoof from there. But if you have identified such a person or such an institution or such an organization, what you should be doing is, well, closing on them and filter on their edge as close as possible to their source network. There was a presentation from, I think, CZNIC yesterday about the secure VLAN, which also had more information about this. So another thing you can do, but this is not for defending, but this is more for blocking, which is interesting because I also work on things like Tor projects. There's the reverse of that. If we have malicious domains like banking scammers, like somebody registers the bankoflondon.com, which is then not the original one. They will send you an email. Your users will click on the email and they'll go, oh, to the bank, click. They will type in their data because, well, users are stupid. And thus you will have problems because your user just gave away their credit card information or their bank information, and their bank will be emptied, and you will have, well, a user who's unhappy. So one thing you can do is you can use response policy zones. And these are also dubbed DNS firewalls. And you can configure, for instance, that the bankoflondon.com, if you know that it's a bad one, that it should actually redirect to, for instance, a website, which is maybe your little portal, which instructs the user, hey, this is a bad website, you should not go there. You can also give it an answer that the entry does just not exist in DNS, and so on. I'll have slides about that next. So DNS is, or RPZ is an integral part of DNS. You just fill in a zone file with this information, and then you can use the standard ways of distributing this information to other DNS servers. So for instance, you can say if the name being looked up is W, for instance, if it is the bankoflondon.com, then a certain action should be taken. You can also look at the IP addresses in the system. You can also look at which name servers are being used, because a lot of malicious operators, they will use one set of name servers for hosting maybe 10,000 domains. So if you know that a certain name server only hosts malicious domains, you can block that whole thing in one go. For instance, you can have an affected.example, and you can simply say a CNAME to dot, which indicates for FPZ that you are not going to give an answer back. This will return an NX domain. And for a client, it simply looks like that nothing is actually there. You can also return it to star dot, and it will return no data, which can be useful for other cases. Because NX domain is sometimes caught by certain operators, for instance. You can also simply point it to www.antivirus, that example, so that when the user goes there, that they actually get to the antivirus website, where they will get information about how to solve their problem there. And of course, you can answer with the real entry if you really want to. So for instance, there's Spamhaus does this, IAD has an RPZ feed, Serble does this, Paul has his own private feed for at home, where he puts in a lot of entries which are bad for the kids, because he has, the youngest one is 13, so. And then we have, you can also, you have to ask permission for these. Typically they're commercial services, or the feeds are available, but you will at least have to ask permission for copying, because effectively you slave from these servers, and thus they need to set that up for you. Well, another subject is that we can do, if you are on a network and you want to actually determine what you want to have in your RPZ zone, so what is malicious information, to figure that out, you can do the DNS query collection. So you can turn on your logging on your bind server, and you can then figure out maybe that bad domain has been requested by a user. At least you then know which user that is and that they went to that site. So what you can do is you could just turn on query logging, which will go to either a file or to syslog, depending on what you want. And then you can, this information you can collect. But if you have a large DNS server, maybe you have 10,000, maybe you have 1 million users, your logging will slow your DNS server down. So this is not a good way of doing it. So an alternative way of doing that is you can do passive DNS. And in this case, you will put a hub or a mirror port in front of your DNS server, and you use a different machine for actually collecting the information. So you sniff the packets of the network. And then you do have to do more tricks, because you have to do TCP reassembly, you have to look at UDP fragments. But the advantages are that you get the full packet details, and you have a lot more control over what you actually see. And you can do this in various locations. You can do this, for instance, on the before the recursor, so that you sit on the client side, or you can do it above the recursor, as you call it, where the recursive cache is still going to ask the authoritative name server. But of course, that is, even though that is great, you have to do the TCP assembly, and you have to do UDP refragmentation, and so it is, you do not always get the information that you want. So Robert Edmonds, a guy in our team, he came up with a new tool, and that's called DNS Tab. It's available on GitHub, and there are patches available already, and typically already released and integrated into bind, unbound, and not, where you can, it's a message passing thing. So when the DNS server itself, so for instance a bind, has actually received the query, for instance for www.enog.net, it will have an internal structure, an internal representation inside the program of how the, what the query looks like. So what we do is we copy this information inside the server, and we log that information. That is much faster, because there's no waiting, there is no waiting for the file to write to disk and everything. So there's nearly no performance penalty here. We have a study which shows how much performance penalty, it's something like 1%. So the information about that you can find at dnstab.info. There's a lot of information about that there. To put it in a bigger overview, so normally I'll walk to this screen. So normally your packets come in. Do you see the red dot? No, you don't. So unfortunately, I'll have to do it here. So the DNS worker thread up here, that is where your queries come in. And you duplicate those then into what you call a circular queue. And from there, you just read it with a different thread. So the normal DNS queries and responses can just keep on going at full speed. And then the DNS thread, he actually logs it. And doing it this way, you avoid this whole performance bottleneck for when you do file writing or when you use syslog, which is a bad thing. Now, you have all this passive information. You can get it out of your query logs, you can get it out of your passive DNS, or you can use DNS Tab. That information, all that feed, all the data that you get, you have to then store somewhere, of course. So we have for that a system called DNSDB, which is, if you are a security researcher, for instance, you get free access to this. The details are, again, on the website for that. There's a web-based query interface, and there's also an API for people who have, well, investigative tools already there. For instance, if you have your own web interface, then you can use a JSON query to request details about this. So as an example, query for Cisco, we ask the system on the website for Cisco, and you get back this information, for instance. So for instance, between 2010 and 2013, Cisco.com pointed to 198.133.219.25. And between 2012, the 12th of March, it changed. It had 2 IP addresses. And between 2013 and 2014, we had that it was a different IP address altogether. And that way you can track and see the history of where a website was and how, well, where it moved around to. Maybe it changed providers. Maybe the malicious entity actually just, well, was changing hosts, or he found another hacked host that he could use for it and abused that. Well, Cisco is not a bad site. But in another way, you can also ask what that IP address actually hosts. And if you have a malicious operator, they typically have like 1,000 domains to point to the same thing. So you know directly, oh, I can blacklist all those 1,000 ones because most likely they're bad. In another way, you can also see maybe there's only one bad guy and the rest is all good. And that will mean that if you would do an IP-based block on this, you would restrict them from accessing the good sites, which would be a bad thing again. In that case, you want to block on DNS level, using, for instance, RPZ. So at that point in time, we had that these domain names were pointing at least to that IP address. And that you will see lots with, of course, large web hosts and so on. Well, to go back to how malicious people do this, so the problem, the big issue is that it's very easy to register the domain name. I just heard that .cz charges $5. There are other domain providers who charge, what, $1 per year or something like that. Then you have the lots of fun stuff, which is called domain name tasting, where you just say, I want to register that domain for a while and see how much traffic I get for that. Then, of course, there's the big issue with stolen credit cards. So the malicious entities already have like thousands of dollars in their bank account. And thus they can, well, register as many domains as they want. So it's very easy for them to create 10,000 London of the Bank of London kind of domains, which are very appropriate, which will be used very nicely for spamming, and which look sort of real, but probably are not. So they typically do a registration, then they do the hosting on it, they propagate their spam, and they propagate their virus botnets and so on, and then they deliver their what you call the payload, which is actually the virus, and then, well, the good people, which I consider me to be, we block those people, and then, well, the whole cycle starts over again because they have the next domain and so on. So we came up with a new system because we have a rather large passive DNS network. And so we have our DNSDB sees almost every DNS query apparently around the world. And so we came up with a very nice system where you do not have to use ZFA. Does anybody here know ZFA except for the ICANN people who are present? Zone file access? No? Okay, so what you can do is you can go to ICANN, you sign a little agreement, and you can get the full list of domains that are registered in .com or in .net, .org, and various others. CCTLDs are typically excluded from this, but you can get a full list. You will get this list about every 24 hours. So after 24 hours, you can at least know that these new domains were registered that day. And most likely, as they're new, they will not have any valid content yet, unless it's the new movie coming out or Apple announces a new iMac or something else, or a new product like an iWatch. Most very likely, there's not something on that yet which actually will have any real value to your users. So any users going to those domains are probably going there because they received a spam with a new domain in it, and they're probably going to click on it. And generate money for malicious people. So what we do though is instead of transferring these ZFI files, which come every 24 hours, we just look at passive DNS. We will see a domain in, well, the moment that somebody tries to look at it, to look it up in DNS, we will see it. And so what we do now is we publish these new domains. So if we have not seen in our passive DNS a domain in the last 10 days, we consider it a fresh domain. And we publish this through an RPZ method. And that way, because you have RPZ, you can locally block all your users in your internet provider from accessing these new domains, and thus you are protecting them from accessing most likely malicious content. And I had my 5 minutes, so I think I'm on time. Any questions? Uh-oh.
Здравствуйте, Александр Зубков.
Hi, my name is Alexander Zubkov and I'm from the Moscow University.
You said about we can block new domains.
Yeah.
Is there any automatic tools for it? Can I do it in bind automatically?
Yeah, so the combination of this is this. We first of all have DNSDB, so we get the information, right? You need, like Spamhaus collects information also through passive DNS, but everybody knows Spamhaus, I assume. But they have a lot of spam traps. So if they get an email in a spam trap and they see the domain name in there, they know it's a bad domain, most very likely. And if you get 100 of those, their accuracy is better. And what they do is they publish this in RPZ, so in the response policy zones. We publish our information also in response policy zones so that anybody can subscribe to that. And then you have the list of information of which zones or which domains are new, fresh. And then you can make, for instance, spam assassin, look up in that zone if there's any, if it is listed in there, you can let spam assassin add a score, like 5 points, and that way block it. But you can also simply put it on your recursor, and then your recursor will answer, for instance, with the policies that I explained here. This one's. So the RPZ will actually point to for instance, the dot, so that there's an NX domain. The user will not resolve it. But you can maybe better in these kind of cases is, from my experience, send it to, for instance, www.antivirus.example, which is your local, if you're an ISP, a local information page showing, hey, you just received the spam, you went to a domain which is bad, please don't do that, and educate the user. Because education of users is extremely difficult. I mean, try to tell your or my mom that they should not click on something. People will, right? And especially as most of them have iPads now, they don't even see the little lock. And even if there's an SSL lock on it, an SSL lock means nothing. It means there's maybe crypted data between you and me, except maybe for some 3-letter agencies who will be able to decode that. It doesn't prove identity, and that is a big problem in the internet. And especially people who click on links in banks, which have banking information like this account is due, they will keep on doing it until you scare them off. And so from my opinion, having something like this, that they click on it, they get to a website like, hey, you almost gave your private information, your banking details, to a criminal. They will have learned their lesson. Does that answer your question? Okay, thanks.
Victor Safronov. DNSDB, does it provide an access to something like common database which was collected from all the DNS tabs or just from mine?
So DNSDB is something we have internally. That is a product, I would say. So people can get access to that. You can build your own. There's various people who have had slides and presentations on how to build it. The scalability is an issue. And of course, getting enough data sources for your DNS database to be meaningful. But yeah, you can build your own if you want. It's not too tricky. MySQL will work for a bit until the data explodes.
I'm a curator, and I have a couple of notes and one question. So the notes. Response rate limiting might be bad for you because it makes cache poisoning easier by a lot. So be careful with that. Second thing, botnet CNC with DNS is so 90s because right now botnets have no CNC.
Well, the botnet, the thing is, indeed, you're completely right. The botnet, they do not use DNS so much anymore. They used to use these, what do you call them, the calculated DGAs, the generated domain names, right? But they don't use that, and they stopped using that stuff. They all do peer-to-peer, and I mean, Zeus is getting pretty nice, actually, from a technical point of view. But they still need to get a message to a user to click on it to get their data. And for 90% of those cases, they will send you a website, a URL or something.
And the question is, first of all, thank you for DNSDB. It's awesome. And here comes the question, demo access. What should I do to have a demo to have the access to DNSDB?
So if you are a security researcher, so you're doing this for your free time, as we call internet superhero work, then that's how we call it, then that access is free. You specify that in your sign-up message, like my affiliation is X, I work for this and this company, but in my free time, I do that and that.
I did so, and I am superhero, sort of. But somehow my account got terminated. So
okay, terminated, you say?
Yep.
Or rejected?
It just went. It's not there anymore for some reason.
I would say send an email. There's an email address on the website. I don't know it by heart, but send an email there. Explain your situation. I'm pretty sure that the people who handle the sign-ups will handle it for you.
Thank you.